please hang around. Yes, my name is Wei Chen, and I represent the SAS Data Analytics Community. Our topics today is regarding the impact of machine learning on insurance pricing. So just to introduce the topic, I mean, as we all know, AI and machine learning is getting a lot of attention and traction in insurance industries. As actuaries ourselves, there's opportunities on how we could leverage them, particularly in the areas of insurance pricing. Our speakers today, they'll be discussing about why is it timely to look at machine learning for pricing, how we could implement machine learning to get and complement that with our traditional method, such as GLM, and what could be the role of an actuary in this process. There will be also a product demo of a machine learning application called Accurate in the second half of the session to illustrate what this process may look like. Yeah. So before we go, just want to announce a few housekeeping items. Firstly, the session is being recorded, and then the material will be made available after the session. Second, please change your names if you haven't done so in Zoom to full registered names so that you can keep track. And for those that are attending, you could entitle the 1 hour of CPD hours. The CPD hours will not be automatically recorded, so it will be up to you to track and record the hours. And finally, at any point of time, if you have questions, please use the Q&A below to ask questions. We will address them at the end of the session. Okay, and now to kick off and introduce our speakers. Our first speaker, Thibaut Imbert, is an insurance solution manager at Munich Re. He previously worked at AXA for 8 years, where he held several positions focused on risk management and pricing before he joined Munich Re as an actuarial consultant. Thibaut holds a Master of Science in Applied Mathematics from École des Mines de Saint-Étienne. Second speaker, Estelle Lebas. She is a client executive at Accurate in charge of APAC market. Prior to that, Estelle had several positions in the insurance industry as task force director at Swiss Re France, as an internal controller at AXA Global Direct, and as client executives at Shift Technology, where she spent 4 years. Estelle holds a master's degree in management from ESCP Europe. And finally, Emeric Blanchard is head of product at Accurate. He started working at AXA Global Direct in the pricing team before joining Comet, which is a startup studio, to contribute to the development of Accurate. He spent 4 years as an actual data scientist before evolving towards the product. He graduated from Telecom Paris Tech. Okay, so I would like to pass the presentation to Thibaut. Yeah, you can take over. Thanks.
Thanks, Wei Chen. Thanks and welcome to this presentation on machine learning and insurance pricing. So before going into the details, I would like to introduce a bit the context. So the context is that we live in a world where what we define as technical sophistication is at the core of insurers' challenges. So we identified, I would say, 6 pillars explaining this reason. So first is insurers focus on technical performance of their book due to a low interest rate environment, and also changing environment now these days due to COVID-19. Also, one other pillar is increased agility and capability to really put models, use IT capabilities to support technical sophistication. This also goes with, I would say, client awareness. So customers are more and more aware, price sensitive, and this is also supported through the entrance of disruptive players. So a lot of insurtech, some tech players are also entering the insurance field. And then also, which leads to, if we get to the 6th point, the de-intermediation, so more and more online channels, so new players, new way of selling, and also new ways of modeling, machine learning, artificial intelligence. And that's the idea of today. How can machine learning support and can be used into insurance pricing. So this is the context where we live in a world where technical sophistication is key and is the differentiating factor for insurers. So just to put also a bit of context more from an algorithm perspective, so what we see usually is that it's something that is ongoing and that always has always existed. So quite surprisingly, the first thing to be invented were more neural networks in around 1950, which are now getting popular due to IT capabilities. Big milestone would be 1972 with the introduction of GLMs, then enhanced and extended via GAMs, so generalized linear model and then generalized additive model. And then more recently, we have the introduction of machine learning techniques, so the most famous being random forest and GBM. But basically that algorithm, the race of algorithm, it's something constant that always existed and that will keep on existing to support the technical sophistication. So first, we will introduce to discuss about machine learning and AutoML. So what is a brief recap? So what is machine learning versus traditional techniques, and then an introduction of what we define as AutoML. Before we start really on the AutoML and the techniques, just to redefine the things also. So insurance pricing, the way as we define it at Munich Re, we don't necessarily think that it's only the rate making process, but pricing, insurance pricing goes way beyond. So, okay, it's about getting a rates, but it's also going into more technical rates, so increasing premium sophistication to target new profitable customers, some market niches, also identifying potentially poorly performing customer, which is done by managing the portfolio. So insurance pricing is also about being capable to manage a book, identify good customers, pruning the bad, and keep the book under control. Also, so growing sales, so which be on acquisition of new client. For example, what should be the optimal market positioning if I want to enter into a new channel? Typically, a price comparison website. How should I compete? What would be the optimal way? Should I go for which price, the cheapest or something more expensive? And what would be the impact of my overall book? And the fourth point would be more entering and designing new products. So, for example, if I want to launch a new product, I have a motor book and I want to expand into household, how should I proceed? This is also what we define of part of insurance pricing. Terminology that we tend to use is day one pricing. So insurance pricing covers all of this. It includes the rate making process, but is not limited to the rate making process and goes beyond this. It includes a new product launch and portfolio management, let's say. In this situation, actuaries tend to face a bit this challenge. So we have, as of now, I would say, in a simple way, two traditional pillars. So the manual pricing. So we talk about potentially Excel spreadsheets, GLMs, and on the other side, we get more and more machine learning algorithms, which are more, I would say, automated and usually more performing. Both are pros and also cons. Typically, manual pricing is something that is long, iterative, and inefficient, we tend to say, meaning that if we want to price for a certain product, the various covers at a good granularity, and let's assume we want to do frequency and severity, we can easily end up with dozens of models, and it can take months because each model has to be done separately. And also, if you want to retrain the model, it can also be time consuming. On the other side, we have machine learning model. They can address these issues, so it's much more scalable. But here comes the problem of explainability. So a bit this black box aspect that is quite often mentioned when we discuss about drawbacks of machine learning algorithm. Here might create problem in adverse selection. So we know some specific client profiles might be mispriced without us realizing, and also regulatory issues. So what we see is that insurance is really an industry which is really specific with strong regulatory constraints. More and more, if we take, for example, the new FCA ruling in the UK, we see that the regulators are putting more and more constraints. So the idea is that there is this challenge on what to use, because each method has some advantages, but has also some drawbacks. And that's here that we introduce the concept of AutoML, which we will address later, as the solution to combine the benefits of these two approaches while limiting the drawbacks. So really getting the explainability of traditional pricing and the scalability of machine learning algorithm. So a brief recap to just dig a bit more into detail when into these two aspects. So if we take, for example, here a GLM rating structure, so we have a client, so it's a customer, drives a 5-year-old BMW M3, car insured that has a current vehicle value, gender, age, location. And here we have some tables, and it's easy to derive the premium. So we can really, by just having a multiplicative structure, computing the premium. We can then also have blocks that we then sum, but the structure is open, it's a closed formula, and it's easy to have access. On the other hand, if we have some machine learning techniques, it's much more difficult. And here is the example of the black box aspect, is what will we use to visualize the model? Because a machine learning algorithm will be more, I would say, a set of rules more than a closed formula. And here, so two things that we tend to use. First, variable importance plot, which really explain and order which variable is the most important. So here we have different variables. So it's some modeled on dummy data, and we have the different variables that appear. And for each and every variable, a partial dependence plot, which tells what for a certain modality is the estimated, so in this case, frequency, but response variable. So we have some things to visualize to get an idea of the model, but it's not as explicit as some GLM GAM models could be. So that's why we think, as I explained, that so here, a quick question before we move, right, is how would you define the status of your technical sophistication? You are using GLMs for less than half of the covers, for the majority of the covers, or you have GLMs that you combine with machine learning model. So it's a question also to understand a bit more how you would use these techniques if you are familiar with it. So then if we introduce AutoML. So what is AutoML? So AutoML is, let's recap the whole process, and it's through the whole process that we will get to see what AutoML is. So basically, if we start at one, so pricing actuary has to start with hypothesis, gather the data, clean the data, understand, prepare the data. So all of these things, we know them, feature engineering, and then train one model, so several models, let's say, through GLMs. What AutoML does is that AutoML automates. Here we have the results. Good. Okay, so we see that basically the usage is around 40% for less than half of the cover, and GLM for the majority of the product cover for 44%, and GLM with machine learning being the minority. So we really see here that's really interesting because we see that the importance of GLM, even if there were some tremendous development, I would say, on the modeling aspect, a lot of new techniques, a lot of new packages, be it in R, in Python, in whatever language, we are still using, and people tend to use GLM still a lot. That's interesting because that's really something that we see also working on different markets, working on European market, American markets, that really GLMs remain the core of it. So basically, so what we are seeing, so we have these GLM that are used by many people doing the modeling. AutoML will help and automate the building process. So the idea is for AutoML will kind of do a grid search on the different possibilities to find an optimal solution with an output which is understood. So that's really about automatizing the search process and then letting the actuary decide on the output being core understandable such that the actuary can really understand and select the model. So the idea is not to remove the actuary from the modeling process, but it's really to support the actuary and to help the actuary on the time-intensive part and to let the actuary focus on what AutoML can provide, so on the results. So the idea is, and through the clarity, expert judgment can be applied, and then models being explainable through GAM models, then they can be actionable, so they can really be used in a real environment, implemented in an IT system if needed, audited, and shared. The good thing also is that on top of the modeling, this grid search, one perk of it is besides the time saving aspect would be the potential to find new KPIs because there is a grid search, new variables. So a lot of possibilities can be used, can be explored, and then many variables can be tested, hypotheses can be tested and easily reviewed. So that's really the idea, to support the actuary in the modeling. And I would say, so here is the comparison with machine learning. So what we can see is that machine learning is something that it's a lot of algorithm focused upon predictiveness, a bit hands-off, so trying some grid search, getting the results, and used throughout different industries. So here we talk about can be online marketing, insurance, banking. On the other hand, if we compare, AutoML will be, as I explained, built around GAM GLM model output. It's more designed for insurance, taking into account all of the constraints. So here we talk about regulation, implementation in the system, so in the pricing engine. Also removing the risk to AI, black box AI, and keeping the pricing actuary at the core of the process. So these are the big difference, with AutoML being more insurance focused and taking into account insurance specificities. And here what we say is that AutoML tends to transform the economy of extracting value from the data set. So it really transform the economics of modeling, so the modeling aspect. So, okay, thanks to this, we can really, so as I was explaining, actually remains at the core, but is being supported. So thanks to this time saved, it's possible to divert the effort. And that's here that we see the value also is saving time, but saving time to focus on other topics, typically, so here are a few examples. So looking for new data sets to potentially enrich the database that we may have and then gain in terms of predictiveness, identify some segments also. So really spending more time on analyzing the books and understanding which profitable segment could be. We could focusing on, and also focusing on the product part. So being capable to price in a sophisticated way more covers. So for example, the windscreen can be left aside initially, but then as time is being saved, also increase the technical sophistication on it. And also focus on the product development and being capable to have products, I would say, more granular with more covers in it. So these 4 points also links with the product development aspect, and in there generating new initiative to be more relevant to the client, focusing on marketing campaigns, understanding the clients, also spending more time maybe on behavioral modeling, being capable to launch new products, so day one pricing, new group schemes. So it's really expanding the offer. So expanding the offer from data perspective, but also from the capabilities from a product perspective and also on the market, towards the market, what can be done. So it really allows to do so. And on the right, we have the payoff, and we really think that it's on the capability to model more cover that the value lies in. So to recap, so we've seen all of these things, the capabilities of AutoML and how they could support the pricing actuary. But as I explained already in a few slides previously, something that is core and that we always put emphasis is that they don't replace the actuary. The actuary remains at the core. And I think the title is pretty clear that domain knowledge wins over algorithm, that really the actuary remains at the core. And we also think that it is even more, the actuaries are even more at the core of the decision-making process, because algorithms take care of the time-consuming aspect, and I can really focus on models understanding, market understanding, and really bringing all of their expertise. One final slide before I hand it over to Estelle. One quick example taken from a real-life project that my colleague and myself worked on. So the idea was to launch a digital insurance platform in the UK. So it's a mix, so M&A, some startup and organic growth, so something quite big. And then we used this AutoML approach for risk pricing and conversion rate modeling, working also on transferring this thing and looking for new data sets. So that was really a real pricing effort. And generally speaking, the result went pretty fine, because here are a few KPIs. So around 45,000 models were trained, a lot of real pricing simulation, all of this being done in an AutoML context. As we had some time, we could also spend some time to enrich the data with new external data and improve the predictiveness on it. And it was a fairly limited team. So we are talking about maybe 4 to 5 people not working full time on it over less than a 6 month to 1 year effort. So we really managed to deliver all of this by leveraging on these capabilities. And this helped us from an operating perspective, but also in terms of predictiveness, because we assessed again that we increased our loss ratio by around, we improved our loss ratio by around 4%. So loss ratio reduced by 4%. So before I hand it over, I have a second poll. So here is about what is your approach regarding modeling. So do you use a professional pricing software from a known brand? We all know there are a few. Is it more something without a known brand, so more open source solution, SAS, R, Python, and or Excel, so no pricing software, or is it a combination of both? Okay, so we see it's fairly balanced. I would say that it's either coding languages, so majority being coding languages and Excel, so more open source things. And also, I would say generally speaking, if we sum 1 and 2, we get around 60% using a professional pricing software, which is okay, what also we see fairly standard when it comes to pricing, but also quite a significant share of open source and Excel. I would say no use of professional pricing software. Great. So now what I will do is I will hand it over to Estelle, who will present us Accurate.
Thank you, Thibaut. So the idea here is to give you a quick overview about Accurate. So if we move to the next slide. Yes, so this is the Accurate overview. So Accurate is an AI insurance pricing company. We launched in 2018 after 4 years of R&D. So we have offices in Paris, New York, London, and we will open an office in Asia next year. We just did a fundraising, so we closed the Series B and we raised $30 million. We are now more than 65 employees worldwide, and the team has a strong tech DNA. So we have data scientists, we have developers, actuaries, and PhDs. So we are offering a SaaS solution, meaning software as a service. We are focusing only on general insurance, so mainly P&C and health, both commercial and personal lines. So as of today, we have more than 30 clients worldwide. We are working with leading insurance carriers such as AXA, Generali, Munich Re, but also with local players and more specifically in Asia with AXA Direct Japan. So if we move to the next slide, our ambition is to transform the insurance pricing with transparent AI. So the idea here, and our value proposition and the way to tackle the market is very unique. So we will automate the modeling process. So thanks to our proprietary algorithms, we will generate various GAM and GLM models. And as the output is GAM and GLM models, we will have traditional and transparent models which remain controllable by the actuaries in order to help the insurers being compliant with the local regulation. So we really combine the best of the two approach that Thibaut explained. We combine the traditional approach and the machine learning approach. So the next slide highlights our value proposition. So Accurate help the insurers to implement a pricing making process which is faster, more accurate, and safer. There are 3 pillars. The first one is the speed. So as we will automate the modeling process, we see that, and our clients say that the models created within Accurate are created 10 times faster. The second pillar is a performance. Thanks to our proprietary algorithms, the model created with Accurate have a predictive power, which is on average 10% better than the models created with other tools. And the third pillar, the transparency. So as the models created are GAM and GLM models, it will avoid the risk of adverse selection and also help the insurer being compliant with the local regulation. In the next slide, you will see our roadmap. So you will see that we have a modular approach, and we will adapt to the level of sophistication of the insurer based on the line of business and on the country. We have different modules, and for today's demo, Emeric will focus on the risk and aggregation module, which is made of the data brick and the risk and aggregation brick. We have also a demand module, which is live, which measures the price sensitivity based on customer behavior. And the last module, which is the rate making and portfolio insights, will be live at the beginning of the year, and it will help insurer to adjust premiums. So I will let the floor to Emric to do a presentation and a demo of the solution.
Thank you, Estelle. So I will run a demo of the presentation. So as you can see right now, I'm connected to the platform. So it's a SAS platform. So you just need to have a password and an email account to be connected. And what you can see here is that I'm logged in a motor insurance demo. So what you will see today will be simulated motor insurance data. But the software perfectly applies to all non-life line of businesses, so health insurance also and commercial insurance without any troubles. On the left, you have access to several sections that correspond to what Estelle described just before. So data section is the section about data upload, data visualization, data cleaning also. Risk is about building risk models, so frequency, severity, and pure premiums. Aggregation is about combining the risk models, so frequency, severity to have pure premiums, and combine pure premiums between coverages to eventually build a finite total pure premium on the portfolio. And demand section that we will not see today is about estimating the conversion rate and the price elasticity on the market. So first of all, data section. So I will use here as example a French database, here French demo. If I click on it, I have access to some meta information of the data. So number of columns here, 253, the number of rows, almost 500,000 rows. Just so that you know, it's a quite small database, meaning that the algorithms works perfectly fine if you have only a few thousand lines to input, but it also works perfectly fine if you have tons of millions of rows to input in the software without any troubles. Very important is that you have access here to a documentation note. So we want to encourage in the software the collaborative access aspect, so that you can your colleagues can collaborate with you on modeling projects. And so you will see almost everywhere in the software this documentation note. Here, for instance, even if I did not upload the dataset, I can understand what it contains. Next, if I want to see in details what I can see in the data, I can enter it, and I can, for instance, look for my driver age variable, and I can see that I have access to the distribution here. So for instance, here for the drivers who are 27, I have 9,140 of them in my data. I have access to some basic statistics to understand whether I am considering the right data set or not, and I have access to the missing values also. Here, what is important is that you can modify the variable, you can modify the levels. So for instance, if you want to rename them, if you want to group them to do a category, or if you want to create new variables, flag them as missing values, everything is included in the software. So it is quite convenient, and it avoids going out of the software if you have any data manipulation. And we released very recently the formulas here. So if you want to basically create a new variable from scratch, you can directly type some code here in Accurate to create new variables. So in a nutshell, on the data section, I go on purpose quickly. It's clearly about understanding your data before going into the modeling. So I will now switch to the risk part, risk section here, so that you can see it. And I will create a new project so that you can follow exactly what I'm doing. So if I click on plus here, you can basically input your project name. And the idea is that you can here select the type of project you are going to build. So either a frequency project to estimate the number of claims, for instance, severity project, pure premium, propensity, or we also have other losses that are interesting. So you can select frequency, then you just need to select the data set on which you want to build your model here, and you create your project on the fly. And the first thing you need to do is to define what you are going to predict here. So you can set goals, and here I will, for instance, create a project predicting the number of claims on property damage. I can input a year variable to be able to assess the time consistency of the models, and I have some exposure also to fill in. And I have also access to model stratification. So this is a best practice in machine learning techniques, is to be able to keep apart one holdout of the data to be able to do some projections using the models. And then you can create the models. And the first screen that you see is presenting all the variables of the data here on the left that are selected, meaning they are candidates to build the models. And the whole idea here is that you may have some reasons not to use some variables because, for instance, you are building constrained models. So there are some variables you cannot use. In France, for instance, we can say that driver gender is not an authorized variable, or because you can have some variables that are a posteriori, so information about other coverages, so you want to remove them. And here you can basically prepare, unselect all the variables that you do not want to consider. In the meantime, you can see that there is a task running. So it's the way the software works. You have asynchronous task running, doing some computations. So right now it's computing the observations for each variable and also a predictive score here so that you can spot very easily the most predictive variables. Here I can see that my vehicle age is quite impactful in terms of predictions about my claim frequency and property damage. So far I didn't build any models. And next step is to actually ask to the software to select a subset of variables among the 200 here that are candidates and build some models. So to do so, I can click on generate models. And here the actuaries have the hand over the complexity, the target complexity for the model. Here it's between 5 and 30, but you can input much more if you want to explore more complex models. And you have two hyperparameters, parsimony and smoothness, that will basically determine the way we explore this range here of variables. So here, if I put, for instance, 8, I will have 8 models that will be built. And smoothness steps, it's about how to fit the coefficients. I will just present it right after. And then you can click on run, and you have a task that is being launched on AWS, on the cloud. So here it will take half an hour to compute for this project, for this 500,000 database, 500,000 rows database. But in the meantime, it's not blocking. So you can still upload new data sets, you can still review other models, so you can still leverage basically accurate while it's computing on this project. Not to lose any time, I will just switch to a project that is already computed here. So let's take this one, it's the same one. So after a few computations, what you can see is this kind of results. So it's presenting here, each point is a model that is produced, and you can see the corresponding complexity, number of variables here, and the performance, which is measured at the Gini, but you can also change it and use, for instance, the expected events ratio without any troubles. And you can see that visually, you can have a good understanding of the best trade-off between the complexity and the performance of the models. For instance, here, you will have access to models that are performing quite good without having too much complexity. And you can see that you can add some variables, but you don't gain much. So it's an actual call on your side to decide what's the best trade-off. Once you've decided which model you want to use, you can just zoom on it and open the model. Here, you have access to two tabs, Overview and Variables. Overview is a quantitative view of the model with the variables that have been selected with their respective impact on the predictions. And on the right, you have access to classical actuarial performance curves like Lorentz curve, lift curve, residuals, and statistics to ensure that the global behavior of the model is correct. And if satisfactory, then you can look at the variable tab. And here you can see on these graphs, on purple, you can see the observed historical signal, so which is quite noisy, makes sense. You can see in orange the model's predictions, so it's less noisy than the purple one, but it's following the same trends. And in green, you have access to the coefficients, so the rates that were presented earlier by Thibaut. So it's what you will use in your final tariff to predict your premiums. And what is very important is that it's a proposal from Accurate, but at the end, it's the actuary that decides the actual values of the coefficients. So for instance, if I look at these variables here, which is the number of claims over the past year, I can see that I have an increasing trend in the historical data, but in the prediction, it has not been captured, and the coefficients does not reflect this trend. And the reason is very simple, is that you have almost no one having 2 or more claims, which is good in a sense, but you still know that this effect is a true effect. So even if you don't have any exposure and that statistically it makes no sense to fit it, you still want to correct this trend and input your own coefficients. And you have the opportunity to do so here, to select the coefficients and to basically increase the value to avoid adverse selection on your side. So it's very important to see Accurate as an enabler for the actuaries. So removing all the time-consuming tasks, but letting, in the end, the expert judgment take its place as needed in the modeling process. So far, I presented GLM models, univariate effects. Just to give you an insight on how it works, if I enrich my model, so basically it's a step-by-step approach. You have a simplistic model with 17 variables that performs quite well, and then you might want to explore if you have some effects, residual effect contained in interactions, so cross effects during across 2 variables. For instance, what's happening between my vehicle age and my payment delay, my vehicle max speed and driver age, for instance. So you can explore it. You can also explore geographic smoothing. So I will just present it to you for this one, geographical smoothing here. So you need to have data location inputs like zip code, for instance, in this case, with latitude and longitude. And you ask the software to generate some models. So here we have asked the software to build 15 different geographical models with 15 different geospatial smoothing to capture the risk. And the result is that here you have models with a very, very strong smoothing, so almost no impact on the predictions. A model with a very, very low smoothing, which is quite noisy. And in between, you have the best performing model, and you can select it. You see that the zip variable is here included with a quite good impact. And you can look at the map in the end, and you can even zoom on the map to see the smoothing effect. And keep in mind that it's always a proposal. So if you want to switch to a model having a smoother effect, it's always possible. You just click on more smoothness here, and you can see it more smooth. So this is quite efficient. And each time you do a next step, then the modeling users still have the end over the output models. Very important also is that you still have access to the previous model. So we provide a clear process to build the models, but you can still understand how we reach the final model in the end, which is not always the case in all the methodologies that were presented by Thibaut before. A few more elements, very quickly, is you can export the models. If you want to use them in production, you can export them. So you can export them, for instance, as a rating table with a base level coefficients. And then if you want to compute the values, you just multiply, taking the right values here, and you have the final predictions. So we have absolutely no will to lock the software. To the contrary, we have an open software so that you can input the models in your existing structure on your side. And we also provide an automatic documentation here. So if you want to have a documentation on your models, you have a basic summary on the database so that you can ensure you are manipulating the right data. You have validation KPIs on the training side and the validation side. And you have access also for each models to the variable importance and to the coefficients that were fitted to the observed and fitted signal. And you have access to see if you left some notes to these notes. So this is a quite formal documentation that is automatically generated and that you can use to share across your team, for instance, on this one. The very last point is how to combine the premiums. Is if you go in aggregation, then you can decide here to basically import models from the risk. So here I wanted to build a third-party liability pure premium. So I needed my body injury pure premium and my property damage pure premium. And to do so, I imported frequency and severity models for each of the coverages, and I combined them. Then I send them to build my third-party liability pure premium here on my model. And then I can investigate what's happening when I combine my models. So here I can have access to the coefficients that were used, to the performance, of course, and to the combined effect to ensure that what my predictions make sense on this one. So here I can see that I'm predicting, for instance, 536 euros for 22 people on average. And I think I will stop here for the demonstration to leave time for the Q&A session.
Thank you, Emeric, for the demos, and thank you, Estelle and Thibaut, for your presentation. We now have about 10 minutes for Q&A. So please feel free to type your questions into the Q&A. We will answer them. I saw one that's being posted. So the question is, for 10 times faster, I think first one of the slides, which parts of the pricing process do you see most of the time saving? Is there any process made obsolete by the automation? I think this one could be either Emeric or Estelle. Yeah.
Yes. So to this question, I think there is something that is key. If you don't need to see accurate only for one cover and one model. So you are 10 times faster in the overall process. For instance, if you want to redo the whole cover, whole tariff for a product, then it's easy to leverage the cloud computing and to launch basically several modeling at the same time. So what it needs you to change your mindset when modeling, to prepare your work at the beginning, not to do it sequentially, but to do it in parallel. And this is truly that's something that is very important. You can either do it 10 times faster, or you can also do it in the faster, but adding some more investigations, like Thibaut said, exploring external data, for instance, extra data set on your side. So basically, it's not on one model that you will reach the most time saving, but on building the whole models on the whole coverage.
Thibaut or Estelle, do you want to add anything to that?
No, I think it's pretty clear. Just one thing on the time saving aspect. I'm just going to speak for myself, being a user of the software. I have to admit that it took at the beginning, it's a bit disturbing because the way things are being done, it seems that like it's taking more time. We need 30 minutes to run the models, but no, in the end, it's a question also of anticipating a bit how the work will be done. So really preparing one thing, letting the model run and being capable to do other things in parallel to really be capable to parallelize, I would say. And that's here that really the gain is the most important.
Okay. Let me ask some questions in the meantime while the participants post their questions. Okay. I'll throw in one question. So what skills and knowledge should actuaries pick up, so that they could contribute in driving machine learning implementation?
I can answer. For me, I think it's so the technical skills on knowing what is behind remain fundamental to understand what the model is doing, what the outcome is, and really being capable to exploit to the fullest this kind of thing. But I think what is really now important also is really, I would say, the industry specific knowledge, the domain knowledge. Here are really things that are even stronger, that were already extremely strong, but even stronger as the new definition on it. And if you want to know more also about it, we just published, we have a slide on it, which a paper that you can see here, the next generation of pricing actuaries. So this is how at Munich Re we expect pricing actuaries to develop in the coming years. So maybe we can put the link in of, you can download this paper in the chat to know more about it.
Yeah, I think although the process could be automated, it's still it's still our role as an actuary to explain what is happening behind the scene.
Exactly.
Yeah.
And we think and we see, because we start using this technique for quite a while now, that it's really something that is core, and it's really that the demand and the expertise is really asked also for some of our clients on some those projects in the UK, where it's really about understanding and keeping the thing, just getting the tool to help to go faster and wider.
And then a follow-up question regarding that. What a usual way, or for yourself, Thibaut, how did you pick up all this knowledge?
But I come from a actual background, and then it's also a bit by exchanging, discussing with my experience come also from discussing with people, being exposed. And I think that's also one of the opportunities that we have in this new solution, is also the capability to be a bit more exposed to other people in the value chain, I would say. So underwriters, marketing, distribution, because that's true that sometimes I felt a bit that spending a lot of time on the modeling aspect was preventing me a bit to understand more the business, what is at stake. And that's really by exchanging and discussing and being capable also potentially to iterate and to adapt based on underwriting feedback, regulation, all of this thing. And this is how I picked up personally, I would say.
We have a couple of questions in the Q&A. Let's address them. So there's a question about how is the model performance compared with traditional GRM pricing model. There's also similar questions about, does it mean that actually needs to select the parameter in advance, or is the AI actually recommending what are the parameters to use? This one will be open to the presenters, yeah?
Okay, so very quickly, I try to answer to all the questions. So on the model performance, since the process is well designed, we do perform well, but it's easy to say, and I can understand it's not so easy to trust. So the way we work, that we offer some free pilots so that you can test the performance on your own data, knowing the data set that you are using. So this is the way we used to work to ensure that the performance is good, but also the level of control and transparency is actually satisfactory on your side. On the second point, yes, the actuary is actually inputting the parameters, but actually if the actuary want to let the algorithms explore a lot of parameters, it's just his call, saying I want to explore hundreds of variables that I have in my data set. So let's do so. Maybe it will not be usable at first because it's too complex, but still you can ask the software to explore many and many signals on your side. So I wouldn't say that you are losing some benefits on this one, just a setup to have. And on the last one, so it's a GLM, so it's very easy to understand whether you used the driver edge variable to discriminate or not. You may have in the end different average prices on your dataset on the, for instance, male, female, gender, but it does not mean you are discriminating. If you never used the driver gender variable, it means that all things being equal, then you are not discriminating. And this is by essence what GAMs provide, GLMs and GAMs provide. And since we are building only GAMs natively, then yes, it's very easy to check it.
Okay, thanks. I think that's time. I mean, we're reaching 4 p.m. Really thank everyone for participating in today's forum. Also, really appreciate our presenters here for joining us and sharing their work. Yeah, thank you very much. Hope everyone have a good weekend ahead. And this is the end of the SAS forum.
Thank you.
Thank you.
Thank you.
Thank you. Bye bye.